Hello friends, our today's question is threesome. Okay, so what is basically given in this question is we are given an integer array nums. We have to return the triplet number I, num j and num k such that I is not equals to j, I is not equals to k and j is not equals to k. And the sum of all the three elements is equals to 0. Okay, so notice there that the solution set must not contain duplicate triplets. Okay, so what is basically given in this question is we are given a nums array and we have to find three values which are not identical, which are not of same indexes, different indexes, and their sum is equals to 0, and we have to return that triplet. Okay, so if we look at this example now, so nums which it is given is 0 1 2 minus 1 and 4. Okay, so output is minus 1 1 and 2. Okay, so because their sum is equals to 0, minus 1 0 1, and their the sum of all three elements is 0. Okay, so what explanation they have given is like num 0 num plus and num 2, they are forming 0 1 minus 1 0 1. Okay, so we are having two times minus 0 1, minus 1 0 and 1 we are having two times, so we have to take the uni because it is given in the here like the triplets we are returning should be unique, so that is why we have written two unique triplets which are forming or giving us the sum as 0. Okay, so this is basically our question. So we have to find those triplets num I num j num k such that I is not equals to j and k and j is not equals to k and the sum is equals to 0. Okay, so this is the basically problem statement in this question. So now if we look at this three sum solution now, so previously we have seen two sum. If you have not seen for that, so we have given the solution for two sum. Also you can find the link in the description. Okay, now what basically we was given in two sum was we are given numbers array and we are given a target of target value. So what we have done, we have to find two numbers from this array that sums to target. Okay, so like in this case 2 and 7, these are the two numbers which sum to target. Okay, so here what approach we have used is we have used two pointer approach. Okay, so two pointer approach, what we have done is we have maintained as it is given this number array is sorted. Okay, so this is sorted first point, so we have used two pointer approach starting from here and here, like one pointing to start and one pointing to the end. So what we have done, we have checked if the sum is greater than the target. Okay, then we have decremented the left pointer because it is sorted, so we will get the number less than uh, we will get number in ascending order. Okay, so if the sum is greater, left and right pointer sum is greater than target, then we have decremented the pointer in, like in this case current sum is 15 plus 2 is 17, it is greater than target, so we have decreased the left end pointer. Okay, now again we have sum it, so it is its sum is 13, so it is also greater than the target, so again we have decremented the left end pointer. Okay, now its sum is 9, so yes, we have written these two indices. Okay, so this is our required solution. So the same way if we consider this now, so like in three sum if we consider this, okay, if we have to find minus 1. Okay, so this can we consider this as our target. Okay, so this if we are considering this current element which is pointed by I as a target, in the remaining element we can find the two indices which will lead to this target. Understood now, like in two sum we are finding two element that is leading to this target. Okay, so in the same in three sum if we consider target to be the current element which is pointed by I, and we can find other two element by using the approach or the logic which we have used in two sum. Okay, so like we will have two pointers here from at starting and end, so we will check like if these two, the value pointed by these two element is equals to target, like is equal sums into target. Okay, so basically we can say like current value, target value, and the value pointed by I, this will be I, the value pointed by j and value pointed by k, so their sum is equals to 0. If it is equals to 0, then we can add this triplet into a solution array. Okay, so I understood the question. Like okay, so again one time we are looking again, so like we will use the approach of two pointer to solve two pointer, like we will use the same approach which is used in two sum to solve this three sum problem. So what basically is we will have three pointers I, j and k. Okay, so what will be, I will iterate it from starting, so I will be static, like at one place only. Now okay, so first of all, for this, like for finding two sum problem, this array was shorted, so this again, this nums array, we need to make it short. Okay, so first we will short it. So now nums array would be like -4, -1, -1, then -4, -1, -1, 0, then 1 and 2. Okay, so we have got our array as sorted array. Now we can implement the approach which we have implemented in two sum. Okay, so what we will do, we will start our we will place our I pointer at the starting. We will iterate all the element up till n-2, because we have to find other two elements also, j and k. Okay, because we have to return the triplets, so we will iterate it I from 0 to n-2. Okay, now j will start from I plus 1 and k will start from the end. Okay, so we will have this pair. Now we will check whether the current, like this, consider this as our target, as we have considered it in two sum. Okay, so this is our target, and we have to find the value of j and k such that I plus j plus k sums to 0. Okay, so what we will do, we will check nums of I plus nums of j plus nums of k. Okay, if it is equals to 0, then we will add this ijk value in our resultant array. Okay, otherwise what we will do, if its sum is greater than 0, okay, in that case we have to decrement the left pointer as we have done in the two sum array, because obviously we will find the smaller value because it is sorted in ascending order, so we will decrement the value of k. Okay, so we will decrement the value of k, so k would be here. Now again, if the sum, like let's say sum we are talking, so if it is greater than 0 now, so we will decrement the value of left pointer, and if it is smaller than 0, then we will increment the right pointer. Okay, that means j value. Okay, so in this case, if it is smaller than current sum is smaller than the 0, then we will increment the like j pointer. Okay, so like let's try run this for first case. Now here one thing is one thing we need to check, like we need to return unique solution must not contain duplicate triplets. So what we will do now, like once we will have, like for I value, like for this let's try run this. Okay, first for first case. Okay, so for 4 we cannot find anything, like if with j -1 and 2 is that is 1. Okay, we are not having any pair that will sum to 0 with I with 4. So what we will do, after iteration we will increment our I pointer. Now j will point here. Let's rub this extra, just a second. Okay, so I will be pointing here, j will be pointing here, and k will be pointing at the end. Okay, now we will see, like I is -1, then j is -1 plus k is 2. Okay, so it will 0, so we have find our pair. So our pair, we will insert this pair. Now again, what we have to choose, one approach is one approach that we can store these pair in set. Okay, so what set will do, it will not contain a duplicate element, but here we have to use extra data structure, because we have to return vector. Okay, so then from set we have to change it into vector, like we have to create another vector and we have to insert value from set to vector, and then we have to return the vector. So instead of that, like here only we can handle the scenario, like we have find -1. Okay, then again -1, and for j, if we don't consider okay, if we don't check for the duplicate value, like j, until or unless now j is equal, because again we don't want to have that same pair. Okay, so what we will do, we will check if j value is equal to, now if j is this, so j will be incremented. Okay, so j will point to this and k will be decremented. Okay, now we will check if j current value is equals to previous value, then we will increment the j value until it is less than k, and in the same way, if k current value is equals to its previous value, then what we will do, we will decrement the k value. Okay, so in this way we will not be having equal, like duplicate value for j and k. Okay, so in this way, if we have this scenario, so in this case that like for this I j k, this will be done, then j value will be incremented, so j will be pointing to j will be pointing here and k will be pointing here, so it will end the loop, because j we will have termination condition when j will be less than k. Okay, so this is the case. Now I will increment here, so I will be here and j will be here and k will be here. Okay, now what we will do, we will again check. Okay, what we will check, I, then so I is there, j is there, k is there. So again we will check -1, 0 and 2. No, it is not forming a 0 for us. Then we will, what we will do, its value is -1. Okay, it is value is greater than 0, so we will decrement the value of k. So k will be here. Okay, now again we will check -1, 0 and 1. So it is giving us 0. So we will insert this pair. Okay, now it is again less than j is less than k, so our loop will be terminated. So in this way we don't have to use any extra space to solve our problem. Okay, so I think we have understood the problem statement. Now looking towards its implementation. So what we will have, first of all we will have our 3 pointers. uh, let's have that. Okay, first of all we see to our vector of int uh, result. Okay, now we will have, okay, now what we will have, for we will iterate for int I is equals to 0, I is less than nums dot size I plus plus. Okay, so we will iterate using I from starting. We have to iterate till and num size -2, because we have to get the 3 pairs. Okay, so this we will do. Now again, now what we will do, we will have int j is equals to I plus 1, then int k is equals to nums dot size -1. Okay, so okay, basically we can have a num and size here. So again and again we don't have to call that. Okay, so it is n-2 and it is n-1. Okay, now what we will do, we will check, we will implement here the approach of two sum. So we will have while j is less than k. Okay, what we will do, if let's say int sum is equals to nums of I plus nums of j plus nums of k. Okay, so if sum is equals to 0, then what we will do, we will result dot push back, we will have our I, j and k, nums of I, nums of j and nums of k. Now we have got our, now we will increment j and we will decrement k. Okay, so we have incremented our j and we have incremented our k. Now here only we will check while, because we, while j is less than k and nums of j is equals to nums of j minus 1. So what we will do, we will increment j pointer. Okay, same way while k is while k is greater than j and nums of k is equals to nums of k plus 1. Okay, what we will do, we will decrement k. So in this way we won't have duplicate value for the same I. Okay, so now this is done. Now else if, now else if sum is greater than, or sum is greater than 0, then what we will do, we have to increment the left pointer. so we will decrement the left pointer, else we will increment the j pointer. Okay, if it is less than. So this is done, and now okay, now we have to return the result, so we will return result after this. One thing we have done, we have forgotten to like sort the array, short, because we need to sort the array. So that is nums dot begin begin and nums dot end. Okay, now let run this code. Pushback, no mention function called pushback. Okay, so here we are having vector of int. Now let's run this. Case one fails. Okay, we are having duplicate value. Okay, so where we have missed while j is less than k j. Okay, so what mistake we have done here is like we are checking for j and we are checking for k, but we have to check for I also, because here like in this case I is having -1 and I is having -1. So for this I, this pair is possible, and for this I, this pair is possible. So again we have to check for I also. So after this while loop we end, so we will, what we will do, we will check while I is less than n. So here we will basically I is less than n -1 and what, okay, nums of I is equals to nums of I plus 1. Okay, so in that case we will increment our I pointer also. Now let's run this. It is accepted. Now let's submit. So it is submitted successfully. Now what is basically the time complexity for this we are calculating. So what basically we have done is, now we have iterated over each pointer and we have checked for I, current I value, whether it is similar to previous value. Then we have incremented I. For the same case we have done for j, and the same we have done for k. If they are having same value as of their previous value, then we have incremented their value, because we don't want to have duplicate set of pair in our result. Okay, so what is the time complexity for this? So basically we are having uh, n log n to short, and then we are iterating. We are having this loop from we are having this loop from starting to end, and we are again iterating from this. So its time complexity for the nr1 would be n square. Okay, so its total time complexity will be n capital O of n square. Okay, so which is good than the brute force approach that we would have used. Like in brute force approach, what we have to check, we should have three pointer I, j and k, and while iterating fixing I and j, then we have to iterate for k for each parameter. Then we need to check like whether they are having sum equals to 0. So this is the brute force approach that we would have used, that would have taken capital O of n cube time complexity. Okay, so this time complexity is much better than this one. So thank you for watching.